let's look at this question, which will allow us to put together everything we've learned so far the last couple of days. Suppose you have an eigenbasis, f sub I, so this means the set f1, f2, and so on, okay? And let's say it's the eigenbasis for operator b, so that's b hat. Okay. Such that, in order of increasing eigenvalues, let's say b hat f1 gives you f1, b hat f2 gives you 3f2, b hat f3 gives you 3f3, b hat f4 gives you 3f4, and let's say b hat, this should be f5, gives you 7f5, and so on. Okay, so that's it in order. What's the eigenvalue for this one? This one, what's the eigenvalue? 1. What's the eigenvalue for this one? 3. And what's the eigenvalue for this one? Okay. So we say, what is the degeneracy of the second level? There are 3 eigenfunctions, linearly independent eigenfunctions, that have an eigenvalue of 3. Okay? And there's only one that has an eigenvalue of 1. Right? So we say this is non-degenerate. We say this is triply degenerate. There are 3 linearly independent functions that have the same eigenvalue. What about this one? This is non-degenerate. Sometimes, here's the case where 1 is equal to 0, just because of the way we use words in English. When we say non-degenerate, we can also say that this is singly degenerate, because the degeneracy is equal to 1. Okay? So when we say the degeneracy is equal to 1, that means singly degenerate. We can also say it's non-degenerate. All right. So these are your eigenfunctions and eigenvalues. Okay. So what if psi happens to be? What if psi is equal to some normalization constant n times f1 plus 2f2 plus 3f3? Okay. According to postulate number 4, what is the probability of obtaining a value of 3 if I were to measure b? So the answer would be equal to what? Probability that I'm going to get b equals 3. Which of these eigenfunctions have an eigenvalue of 3? This one, f2, right? So it's going to be c2 squared. But f3 also has an eigenvalue of 3, so you can add to that the probability that you're going to get the eigenfunction, eigenvalue of f3, so c3 squared, right? Plus c4 squared, because these are the 3 eigenfunctions that have an eigenvalue of 3. So, what would be the answer? What is c2 squared here? Okay, so c1 is equal to 1, is equal to n, right? What is c2? 2n. What is c3? 3n. What is c4? 0. Okay? So the probability that a measurement of property B will give us a value of 3 is going to be equal to c2 squared, which is 2n squared, plus c3 squared, which is 3n squared, plus c4 squared, which is 0 squared. And so what would that be? That's 4 plus 9 times absolute value of n squared, right? Now what is the absolute value of n squared? Do you remember?
What is the last one, 0 squared?
C4 is 0. This is C1 F1, so C1 is n, right? C2 F2, so C2 is 2n. Remember, there's an n right there. And let me rewrite that. Okay, so we're saying psi is equal to n F1 plus 2n F2 plus 3n F3. I'm just distributing my n, okay? Right here. So that is C1 F1 plus C2 F2 plus C3 F3 plus 0 times F4, right? So C4 is, okay? So the fact that this is a 2 and that's a 3, that's just coincidence. Poor choice of, I guess, poor choice of numbers forming got you a little confused there. So. But that's just, it's just the coefficient of function 2. So it is, in this case, it happens to be 2n, and then this is the coefficient of function 4 is 0. Right? So what would be our, well, what do we do to determine absolute value of n squared? We normalize the function, right? Psi must be normalized. So what do you remember from the normalization? Integral of psi star psi d tau is equal to what? If your functions are an orthonormal set, since f1, f2, and 3 are part of an orthonormal set, what is this integral equal to? This is equal to 1, and that's equal to what? C1 squared plus C2 squared, right? Plus C3 squared, plus and so on and so on. You add up all the C squareds, that should add up to 1. Right? See, this is the probability you get the eigenvalue of C of function 1. This is the probability that you get the eigenvalue of function 2, plus the probability that you get the eigenvalue of function 3, and so on. Add up all of those probabilities, they should equal 1. So, what do we get now? What is C1 squared? N squared, right? What is C2 squared? So that means 4n squared. You've already seen that, right? And what is C3 squared? 9n squared. And everything else would be 0, right? So that means that 1 is equal to 1 plus 4 plus 9, that is 14 times absolute value of n squared. Absolute value of n squared is 1 over 14. So to answer our, so what is n? 1. Absolute value of n is 1 over square root of 14. So to answer our question, we say the answer is, that is n squared. So 114. So it's going to be 4 plus 9, 13 times 1 over 14. So 13 out of 14. So the probability that you're going to get 3 if you measure property B is C2 squared plus C3 squared plus C4 squared, because F2, F3, and F4 have an eigenvalue of 3. Okay? And so if you add up all those probabilities, you get 13 out of 14. Okay? What if, okay, let me give you another example. What if psi is equal to normalization constant times 3f1 plus 4f3? Okay? What is the probability that the measurement of B will give you 1? That's just going to be equal to what? C1 squared. Okay? So what is C1? Not 3. 3n, right? So it's going to be 3 absolute value of n squared. So that's 9 absolute value of n squared. Okay? What's the probability that you're going to get B equals 2? There's there's an eigenfunction that has an eigenvalue of 2. An eigenvalue of 2 is not allowed, right? So 0. What's the probability that you're going to get b equals 3? B equals 3, there are 3 eigenfunctions that have an eigenvalue of 3. So the answer there is C2 squared plus C3 squared plus C4 squared. The coefficient of F2 squared plus the coefficient of F3 squared plus the coefficient of F4 squared. Because F2, F3, and F4 will all give you an eigenvalue of 3. So what will be this answer right here? It's going to be 3n squared. Oh, sorry. What's the coefficient of F2? 0. Plus coefficient of F3? 4n squared. What's the coefficient of F4? 0. Okay, how do we determine n squared? So C1 squared plus C3 squared, is equal to 1, right? Because those are the only ones that contribute to your psi. So you're going to say then that what? C1 is how much? So you have 3 times 3n absolute value squared plus absolute value of 4n squared is equal to 1. Okay? So that's C1 squared plus C3 squared must be equal to 1. So that's 9 plus 16. Absolute value of n squared equals 1. So absolute value of n squared is 1 over 25. So absolute value of n is just 1 over 5. So the normalized function here is what? What's another way of writing this normalized psi? It can be 3 over 5 f1 plus 4 over 5 f3. Okay? But that's not really necessarily the truth because we only know the absolute value of n. So this is just n. So it could be a negative 5 instead of a 5.